Right. Streaming or not, here I come. Alright. So I am streaming, yes. And today I was thinking of, yeah, pretty much doing what I did yesterday. But so yesterday I implemented the dynamic arrays from scratch in C. And today I think I will implement hash tables from scratch in C. Again, something I've done in the past, but yeah, I think I can maybe do it better, and so yeah. So let's start by copying around stuff I used yesterday. So dynamic array C-length format here, then mason.build here, then okay, there. Let's make all of those. Also, I forgot to dynamic array. Forgot to fix a bug that I had yesterday. Yeah. Am I okay? Just a slight bug, I think, in the realloc that I realized when I had my thing. So it's here. It's size of t times capacity. And I think if we do ninja, yeah, and if we do ninja test criterion, it works as well. So sage fix realloc not using size of t no GPG sign. Alright. So yeah, just a small bug that I discovered yesterday but forgot to fix in the main repo. So now touch. How am I going to call this? HT for hash table or HT? I don't know. Just yeah, HT is fine. CH like so. And let's touch test ht.c and let's cp this, but the src one into src. Let's copy the test one into test. Alright, I think that's most of the boilerplate done. So this is ht. This is ht. This is a hash table. Yeah, don't have an example yet. So for now, ninja mason setup build. Yeah, ninja c build, and then we'll see. Yeah. Oh fuck. So then I think it's test criterion. So alright. So now let's do some ht.h. Alright, and this time I don't think I'm gonna mess around with like trying to make it like generic. Trying to make it yeah, just yeah, I don't think I want to mess around with like pseudo generics, like the stuff I did for the dynamic array, where I have like you call the header to generate the functions for multiple types, and like you have a dynamic array for ints, dynamic array for floats, and so on and so on. Even though it was cool to explore, I think today I will just switch it up and do my first implementation just as a mapping, as a hash table where the keys are strings and the element, the value it points to is the value associated with the string is just an integer, because yeah, that's simple to explain for like a later video, like an educational video. And then after that, I think, well, if I feel like it, I will maybe re-implement that but with void pointers, because also that's what people wanted me to do yesterday. So I can show it as well in this stream, I guess. So if and def, I don't know, ht like so, define and if. So maybe I should explain how I'm going to implement this, because there is like multiple method to implementing a hash table. One of those is you just have a big array, and then you hash the key, and it gives you an index in that array. And so you do that for all keys, but for this hash table, you always have to like keep in mind that there is a possibility of collision between the key. So like, since you don't have an infinite array, maybe you have like an array of 1,000 places, but at some point, if you have like more than 1,000 keys bound, that two keys are gonna have the same slot, like the same index in the array. And so you have to handle collisions in a smart way. One way of doing this is that if there is already an element at this index, you just do +1, but yeah, I don't know. I'm not sure how well that would work. The way I did it in the past is just that each bucket, each element of the array is actually a linked list, where if there is a collision, you just add an element to the linked list, which I think is what I'm gonna do again. Collision resolution. I don't know, maybe let's read about choosing a hash function. Collision resolution. A search algorithm that uses hashing consists of two parts. The first part is computing the hash function, which transforms the search key into an array index. Yeah, that's fine. The ideal case is such that no two search keys hashes to the same array index. However, this is not always the case and is impossible to guarantee for unseen given data. And the second part of the algorithm is collision resolution. The two common methods for collision resolutions are separate chaining and open addressing. Okay, let's see. So this is the technique I was explaining just a few seconds ago, where if there is a collision, you have a linked list where you can have multiple entries per index in your array. And otherwise, if there is no collision, it's just a linked list with one element. Separate chaining. In separate chaining, the process involves building a linked list with key value pairs. The collided items are chained together. So yeah, I already know about this. Caching locality or reference. Yeah, okay, so this is inefficient for cache. Cache conscious variance of the collision array, separate chaining to a dynamic array. Ah, okay, yeah. Huh, that's interesting. That's very interesting. But I guess for still an educational project, indeed it makes a lot more sense to have a dynamic array to represent the possible collisions. But I think for educational purposes, having a linked list is easier, probably. Because most people already know what linked lists are. Open addressing. Yeah, I think this is a thing I mentioned first, where you just increment the value or something. Open addressing is another collision resolution technique in which every entry record is stored in the bucket array itself, and the hash resolution is performed through probing. When a new entry has to be inserted, the buckets are examined, starting with a hashed to slot and proceeding in some probe sequence until an unoccupied slot is found. When searching for an entry, the buckets are scanned in the same sequence until either the target record is found or an unused array slot is found, which indicates an unsuccessful search. Okay, but then I have to keep like literally the key next to the thing. Like every entry record is stored in the bucket array itself, and the hash resolution is performed through probing. Linear probing, in which the interval between probes is fixed, usually 1. Quadratic probing, in which the interval between probes, adding successive output. I've never done this, but since the slots are located in successive location, linear probing could lead to better utilization of CPU cache due to locality of reference, resulting in reduced memory latency. But what happened like if you do what is it called, linear probing, and like you have a first collision, and so you increment by 1. Hash collision. So in this case, like John Smith and Sandra D are both in collision. So John Smith will go there, Sandra D will go one below because it just increments it by 1, linear probing. That's fine. But then what happens to Ted Baker, which would have liked to be... Ah, okay, it also just goes to the next one. That's maybe actually simple to implement. Hash collision resolved by open addressing with linear probing, interval 1. Note that Ted Baker has a unique hash, but nevertheless collided with Sandra Dean that had previously collided with John Smith. Open addressing or closed hashing is a method of collision resolution in a hash table, which, with this method, a hash collision is resolved by probing or searching through alternative locations in the array, the probe sequence, until either the target record is found or an unused array slot is found, which indicates that there is no such key in the table. Well-known probe sequences include linear probing, quadratic probing, double hashing, in which the interval between probes is fixed for each record but is computed by another hash function. Well, actually, this seems simpler to implement. And also, I've already done this in the past. But I do think like this technique may be more useful for someone learning about it, because that's, I think, what is used in the real world, if I'm not mistaken. Cuckoo hashing is a form of open addressing collision resolution technique that guarantees O of big O of 1, worst case, lookup complexity constant. Okay, I'm not... Hookscope hashing. God damn it, they have the... Coalesced hashing. Other collision resolution technique based on open addressing. Robin Hood hashing. Dynamic resizing. Resizing by moving all entries. Alternative to all at once rehashing. Performance. Associative array. Database indexing. Caches sets. Do they say if they use open addressing? Hashmap hash set. For example, I know Rust has like a bit of implementation detail. Stable, I think. Hashmap, okay. By default, hashmap uses a hashing algorithm selected to hash DOS attacked. Oh, there is hash DOS attacks. Like there is also regex attacks. There is also hash table attacks. That's kinda neat. Zip hash. Is randomly seeded, but a reasonable best effort is made to generate this seed from a high quality, secure source of randomness provided by. Oh, a hash map is implemented with quadratic probing and SIMD lookup. Ooh, that sounds fancy. SIMD lookup. How would you do that? Okay, I'm guessing. This is okay. So the open addressing thing is actually used in real life. Scratch what I said before. So maybe I should just implement that since it's what is used in real life. Although I would like to implement linear probing instead of quadratic probing because it sounds in which the interval between probes is increased by adding the successive outputs of a quadratic polynomial to the value given by the original hash computation. That sounds a bit too fancy for an educational video. So yeah, linear probing seems nice. And also they say they use SIMD lookup. That's... I wonder how they would do that. SIMD lookup. I'm guessing the source for this is like huge, and like I wouldn't really want to know it, to read it. Also, it's mostly documentation here, I feel like. Hash brown, hash map, base. Okay, well, alright then. Let's do an open addressing implementation. I've never done this, but should be fun. So, basically, I can do type def structs. Let's call it ht hash table. Maybe, yeah, I don't know. Hash table. Yeah, I don't know why I'm bothering with long names. Or like abbreviations. I think just having hash table is fine, and like ht as a variable name. And so it has basically an array. And for my first example, it's just gonna be an array of strings. And so this is like buckets. Mm, Really, we could do like something in the style of buckets length count, like so, and then define buckets count to be something like 1060, 20, I don't know, 24. Yeah, then, and that's it, I think. Do we need anything else? Oh wait, no, we need somewhere to store the ints. So, huh. Mm-hmm. Do I store the hash function inside of the hash table? I think that would be wise, I guess. Well, in my case, since it will only be strings, I think we don't have to do that. I don't know. I do not know. Maybe I need something like a struct hash table entry, which will just be a key, a string key, and a value, which is an integer, and this will just be hash table entry, like so. So the buckets have this. I think we do need to store the string. Otherwise, we do need to store the string, otherwise what? Otherwise, when we do probing, we won't be able to like compare the key, I think. So yeah, and show this struct is useless, and we can just have it like this. Doesn't work. After top level declarator. Guess including this in parentheses will not work. Oh yeah, right. This. Okay, this is gonna get confusing. I think maybe I need this. Oh, okay. Yeah, that's very confusing, but that is very confusing. Yeah, let's not do that. It will just confuse people. I'm not gonna explain. I don't want to explain how like the type def works, and like I don't know, whatever the weird type spiral technique is in C to understand. So yeah, let's just keep it in a struct even though it has only one field, which is a bit counterintuitive, but oh well. And so I can do hash table new, which will return hash table pointer And this takes, well, nothing. Then we'll have a void hash table destroy, which will take hash table pointer and nothing for now. Then we need a hash table insert, which will take a hash table, a key, and a value. Then we have hash table delete, which will take just this, and maybe it can return an int. Why not? Actually, let's not do that. Let's just make it void. It will be easier later, I think. And just get which again does this, but returns an int. And I think that's basically it. That's basically all we need as an interface for the user, for this small example at least. Let's put that on the side. And so include no, ht.h. So let's do this up. So here we just do hash table ht is equal to malloc size of hash table. And again, wait, let me do dynamic array utils. Let me just quickly copy paste this. Include std.lib. And this is static. And here we're gonna do xmalloc. Okay, we do xmalloc and that's it. Return ht. Next we need to destroy it, but that's just a free. Wait, no, it's not just a free. It is not just a free. And actually here we don't, it's not just a malloc, we also have to make sure the keys and values are 0. So especially the keys, I think we want them to be null. So we're gonna do memset ht buckets. We're gonna just 0 and just the length of it. So I'm guessing then we just do size of ht buckets like so. And I think this is maybe string. Yep. So destroy. This is, oops, what the fuck happened? I do not know. So all we need to do is free every single string, because we're gonna do like duplicate the key every time. We're gonna do strdip to like not worry about like external allocation or whatever. Make it simple. So we just do a for size t I is equal to 0 while I is below bucket count I plus plus. We just do ht buckets I key, and we free this. And I've learned that if key is null, free does nothing, so that's fine. And that's basically it. And then we just free ht. And I think that's pretty much it. Yep. Okay. Then we just copy the 3 of those for now. So this is ht, this is key, this is a value. And so we need a hashing function. Static, I think it's gonna return a size t, and it's gonna be called hash, and it's gonna take a key, like so. Let's see, hash function. Hash function h maps the universe u to indices, yes, that's fine. Perfect hash function doesn't exist, just give me some easy stuff. Okay, I can't do that. I mean, like it's just modulo. Hashing by multiplication, choosing hash function. For open addressing schemes, the hash function should always avoid clustering. The mapping of 2 or more key consecutive slots, such as clustering, may cause lookup to skyrocket. Is there maybe a simple hash function? ft. That's where I did my first implementation of a hash table, if I'm not mistaken. Yes. ht set, I think. ft stop. So again, I mean, I use like void pointers and such, but so hash table key value and delete. So yeah, that's the one I want. I want a ft hash. Hash. Okay. Oops. So it takes a key. Then I have okay. I think I picked this up from Python. Let's see. How did I get this? Python dictionary hash function. Hashing a dictionary. What hash algorithm does Python use? Yep, that's exactly that. I mean, kinda. Okay, never mind. It's not exactly that, but similar. Simple hashing function for hash table. Basics of a hash table, hashing and hash table. Simple hash function. I mean, I think if it's only a simple one, I can design one myself with just modulo and addition. Try SDBM. Word counter. Hash address minus hash address. Okay, let's just try to write one myself, which I think would be easier. We just do size t digest is equal to 0. Let's start with 1 maybe. And we do just for key different than \0 key plus plus. Let's point out that we are not going to modify it. And all we do is digest times equal. I think we could do plus, but since the key are like the thing is very small, like it's a character, I think we could generate more randomness by just doing multiplication, if I'm not mistaken. Digest at the end. Times e, and then digest, we just do modulo equal to bucket count. So we times it by that. We make sure to do it modulo. Yep. Maybe I can do that at the end. Like, yeah, but if it's a long string, it will overflow. I guess overflow, if we want randomness, is a good thing. But I don't know, I just don't like the idea of it. Unused function hash, but not for long. So, what we need to do next is we need to do get into buckets, and then the index is wait, we need to do like a do while loop, I think. Do while increment like probe maybe is equal to 0, where we do like this hash key plus probe. So there we have a thing, and we need to key. And I think we need to do all this modulo bucket count is different than null. Actually, maybe we don't need to do while loop. So while it's different than null, we do probe plus plus. We try the next spot. Can we do? I think we also need like to make sure like if probe is greater than bucket count, we do abort. Like, because this means that there is no more room in the hash table. Yep. Yeah, that's fine. Then what we need to do is we do hash table entry is equal to null. Can we do entry is equal to no? Yeah, no, that's real. I guess we can just copy paste that again. Which is kind of weird, I guess. This is what I want, I think. Actually, shouldn't I use the get for that? Ah, yes, but the get only returns an integer. It doesn't return like the whole entry. Uh, I guess I could like make a static function that returns the whole entry. Just get entry of a hash table ht char key like so, which is basically this. Which is basically this, and hash table entry entry is equal to null. Yeah, actually, I don't need this. I just need this, and I just need to return the address of this. Must use what? Must use struct tag eyes. Like so. So this returns the whole entry, otherwise aborts. I guess we could like return null here, be slightly cleaner. Yep, that's fine. And so here all we do is struct hash table entry is equal to get entry of ht key like so. We can remove all that. Yeah, I guess abort is fine for this specific case. And then we just do entry key is equal to cldup of key. What do you mean, cldup? Oh, just need the like strings as well. Cldup. Am I confused somehow? Mine cldup. This is in string. Yeah. Why? Okay. Don't really get it, but what is rc strdup a? Are similar but use allocate. Oh, okay. Who cares? Okay, I think I will need a x strdup, which is same as xmalloc. X strdup, which will just be char, whatever, const s. Okay, whatever. So this is S, this is strdup. It returns whatever it returns. Yeah, just do that, and that's fine. I still don't understand like why it's not there. Do I need to X open source? Maybe I need this flag. I don't know. Maybe I need this flag and define this. Okay, apparently I need this flag. X strdup, yes. So we have a key, and then we do entry. So it's insert value, it's equal to value. And that's pretty much it, I think, for the insert. Let's implement the delete. Indeed, this is, I think, much simpler than a linked list, at least for now. Although this is like I think the most basic form of hash table, but still nice to implement. It's quite a bit simpler than with linked lists and so on. HT, this is still the key. And so we delete an entry, so here, same thing again, we get the entry, but it's just that the entry key, we can free it. Wait, actually, like what if it does not exist? Well, if it doesn't exist, it will be null, and so it's okay to free it as well. And we do entry key is equal to null, and entry, yeah, value is equal to 0. That makes sense to me. That makes sense to me. And so it will get entry. Okay, yeah. Actually, I should maybe call those bucket instead of entry. Can I do this? Bucket. Yes. Bucket. Bucket. Buckets. Incompatible type. Yes. Okay. Is there an entry somewhere else? No. They are all called bucket, which is fine. So delete is implemented. And now let's implement get, which should be rather simple as well. We get the bucket. We get the bucket, and then we just return like I guess if bucket key is equal to null, we need to abort, because you should never like get something that does not exist. Otherwise, we return bucket value, and yeah, that's basically our hash table. Quite simple, I think. Yeah, that's. I think that's very nice. That's a very nice example for an educational video. I do have to specify that this hash function is terrible and probably shouldn't be used. But that's it. Like it kind of exemplifies in an okay manner what a hash function is. Just basically taking a bunch of data and converting it to mapping it to a single integer in this case. So, yep. Let's start writing some unit tests for this and see how wrong do I got it. But first, let's do git ignore. Let's ignore the cache and let's ignore the build. Ninja, test criterion. So, test hash table. Let's see, include criterion, and we're gonna want to do, let's see, let's do them in order, I guess. Test ht hash table new. Sure, that's okay. hash table new, we just do hash table ht is equal to hash table new, like so, and you have to here assert not null ht, and that's basically it. I mean, I guess we could like do for size t I is equal to 0 while I is below a bucket count I plus plus cr assert null assert null of ht buckets I key. Yep. Let's assert that all the pointers are null when like correctly initialized. And let's assert also equal I value 0. Let's see, does that work? It does. Make it fail on purpose. It fails. Alright, test hash table destroy. So we're gonna create a new one. We're gonna do hash table destroy of hash table, and this one is just like a don't crash kind of thing. Next we're gonna do test. Maybe let's run it, make sure it passes. Yes, it does. Next is so we have destroy, then we have just insert delete get, and that's all I get, and that's all I have. Hash table insert. Hash table insert. So I do need this one. Then I do hash table insert ht. Then we have a string that is just foo and it maps to 42. And then we have to. I guess I'm gonna use hash table get inside the hash table insert thing, which is not great, but oh wait, oh well. Value is equal hash table get ht foo Actually, I'm realizing now that we don't have any correct way to check if a key is inside of the hash table. So I need to fix that. And we need to see here assert equal value 42. But yeah, so for now I just crash if the value is not inside of the thing. And I don't really want to, of course, return like -1 or some garbage value. Like if we return the pointer, it would be okay to return null, but in our case, maybe not. What is assert? I've heard of it, but it's confusing. Here it's for unit testing. So in this case, it's a library that asserts, but this will just basically mark the test as fail if like a value is not 42. Like, but you have like a much simpler one in the standard library of C, for example. I think would be much better to exemplify the thing. So if you just have like some basic main like so, and you include the assert header assert.h, you can actually assert anything like that is 1 equals to 1, for example. Oops. And then gcc t.c and a.out. and you see nothing happens. But what if you do is 1 equal to 0? Of course, that's false. And then when you run that, it's gonna do assertion failed, and it's gonna just completely exit the program. It's basically like if you do that in like your just regular programming, like in your runtime, I mean, like in your just your regular code. That's like maybe like a sanity check, like to maybe check that an index is not out of bound of an array, or I don't know, to check that a value is not null. If like you're too lazy to do an if and then return and so on and so on, just thing that you know is never gonna happen, but you still want to make sure in code that it never is possible that it happens, like a sanity check. And so that's basically how you use assert for just regular code. But for unit testing, which is what I'm doing now, assertion is gonna, so each of those tests is like a little program. And if this assertion fail, it's gonna mark my test as failed, like here, for example. And if the assertion is true, it's gonna mark it as passing. So it's just a way to make sure that the code that I wrote behaves correctly. Nothing more, nothing less. And to make it it's a bit more complex than the regular assert, because it's just handy to have shortcuts for like stuff that you assert all the time. So that's why there is like 1,000 of them. So if you can see that if I do assert, there is assert not null, assert equal, assert greater than, lower than, and so on and so on and so on. So there is just a bunch of helper or shortcuts assert. Right. So that's insert. Let's see, that does not work. It crashed. So that doesn't crash, but then the get crashes, I'm guessing. Okay. So we know that the get does not work. Assert is what I needed. Thanks. Yep, no problem. But if you ever try to write unit testing, I think the library I use, Criterion, is quite nice. The best one I found in for C at least. So yeah. Should probably remove this. So I can insert, I cannot retrieve it. So here I think I should maybe return null. Not sure. And like according to the context, if bucket is equal to null, abort, because we cannot insert in a hash table that is full. For the delete, well, if there is no entry, if there is no more entry for that one, it's kind of already deleted, so just return. So we do nothing on the delete. Yes, since it's already not there. That's I don't know if that's correct behavior. Yeah, I guess it's fine. And so oh yeah, but I'm stupid kinda. Okay, I cannot like use get bucket for all of these. Because this is like get the next available bucket, but I want to get the actual bucket that is correlated to the key. Do you have a hash function right now? Yeah, I do. But it's like a handmade one, since I'm just doing this for educational purposes. So this is my hashing function. I just multiply all the characters in my string and then modulo the length of the array for now. So yeah, pretty shitty hash function. But yeah, I was just reading about this Stack Overflow post that shows like simpler but better hash functions. And yeah, maybe what about collision? Yeah, collision for collision, I'm doing like my previous implementation used separate chaining, but for now I'm just gonna use open addressing. So if there is a collision, I just go to the next bucket, and if that bucket is available, that's the bucket of the key, basically. Very simple way of doing it. And there is more optimized version of with quadratic probing, like where you don't go just the next one, but like a bunch of next one according to a polynomial or something. But too fancy. I just want to learn about it and make a video about it. So yeah. I got it a bit wrong. So get bucket will get the next available bucket. It doesn't actually get the bucket. Maybe available buckets. So this is get available bucket. And here we just do abort indeed, because there is no way of doing to get the available one if it doesn't exist. But for delete and get, we actually don't want the available one, we want the actual one. And so let's do a little bit of copy pasty. Fuck's sake, the noise outside of my house is making me go insane. But I don't think you can hear it through the mic. I don't think. So this is similar, but while key different than null. So for fuck's sake, the guy screaming in the microphone. Shut up, my dude. Yeah, on stream I probably look insane, like talking to myself, but there is like a carnival outside. So I go over the buckets, hash the key, and then my probe is just an increment. But I have to modify slightly the condition where if the key is different than null, so while it's different than null, and this str compare of this and key. Okay, let's rewrite digest is equal to just hash of key. Okay, then we need to do not sure, do while maybe. whatever. Let's make an infinite loop for now. Then hash table bucket is equal to this ht buckets digest plus probe, like so. And I still need to do modulo bucket buckets count. I guess I need to do a struct kind of thing. I'll put that on a separate line. So I do if bucket key is equal to null, then well, we don't have a response, so we return null, like it doesn't exist. If bucket key, and then we do the str compare of key of the bucket key and the key is equal to 0, we do return bucket, since we found the correct bucket. Otherwise, we do probe plus plus, and we have still the condition that if we run out of thing, so if we did the whole array, well, this time I don't think we want to abort, we can just return null again. And yeah, that's basically it. And I think we can delete that. Can I refactor that so that it's not retarded? Can I do like a for loop maybe? Where this is a start, then we have this, and the while is while probe below bucket count, probe plus plus, I think. Don't need that anymore. Oh wait, I do need it because that's only at the start. Oh, fuck it. No for loops, but just a while loop, and we do while probe is below bucket count. Sounds fine by me. Actually, it can be a for loop. Just probe plus plus, and size probe is equal to 0. And this is a for loop, and this is a for loop, and here we return null if it doesn't work. This we can remove. So probe is equal to 0, then it gets the bucket at that probe plus the digest. Then if the key is equal to null, it means that it does not exist. If the key matches the key that we asked for, then we just return the bucket. And yeah, seems fine by me. Yeah. And so yep, that seems fine. Let's go back to the tests. Let's see. Are you able to? Whoops. Are you able to get it? Yes. No crash this time. Let's see. Yes. And if I do 43, then it should fail. Okay, that's nice. That is nice. Let's do test hash table. I mean, that's already kind of test in insert and get. Next, we want to do test hash table delete. where we do this, and then we do hash table, delete ht, and we delete foo. And it's passing. Okay. And what if I try to delete some random thing? Passing as well. But if I try to delete a random thing and abort, this should fail. Yeah. But if I do this, foo should pass. Yes, okay. Okay. So I think we have what we want, except here if it does not contain the thing we abort, so we have no way of checking if a key exists inside of the hash table. So what we need to do is add one that is hash table contains. And this is just a boolean, like so, and we return just it's just basically return get bucket is equal to null, I think. So yeah, if we haven't found the key anywhere, we just return null. We can do ht.h, we can go here, include city bool, like so, and here it's a boolean, and it contains, and still the same signature, and tests. We have delete, and here we can do cr assert, assert true? No, we can just do cr assert not hash table contains ht foo. Actually, no, we want to assert that it is contained here, but that here it is not contained anymore. Fuck. ht.c. How did I implement this? So get bucket, oh, contains, different than null, of course. Okay, so it's passing. I guess it would be nice to assert that it contains foo here as well. And yeah, that seems... it's also a good test for contains, I guess. Yeah, that's basically all the tests for my small hash table. Seems to be working. Seems to be working. I should try maybe collisions, I guess. I guess I should try collisions. One thing that I haven't tested is if we insert the same key. Test hash table insert same key. It's fine, but then we insert 43, and what we need to do here is 43. And I think now it won't work, but let's do maybe just the opposite, like so. Okay, now it doesn't work. But if I remove the first one, of course it works. Yeah. So what I haven't planned in my thing is is if we want to insert on the same one, get available buckets. Actually, maybe I could reuse getBucket for the insert one as well. It's just that so if I arrive on a key that is null, I know that it does not exist, but can't I just still return bucket and then check the thing? Yeah, like so. Poom. And for the insert, can I just use getBucket, which will either give me the next free one, or will it give me the next free one though? Yes, I think it will. I think it will. So digest plus probe. And if the key is null, it will just return that bucket. If it's not null, but it's the same key, it will return also that bucket. So yeah, I think we don't need that one. And we can put that one above, like so. And the tricky part is if bucket key is equal to null, we we duplicate the key, we add the key. Although, and the value, we just always update it. And the contains is I think okay. I need to do like struct hash table bucket bucket is equal to this, and it's either if bucket is equal to null or bucket no, it's different than null, and bucket key is also different than null. Yes, okay, that works now. Okay, so that's like a proper insert. And also I only have like one get bucket now, which is nice. And the whole implementation is about 90 lines of code, which is nice for as an educational example as well. Anything else that I'm missing out? So the same key. We know that deleting multiple times should do nothing. Delete multiple already non-existent key should do nothing. Make sure it does not do nothing. It doesn't do anything. So yeah, that's fine. Maybe let's test that hash table delete no get non-existence crash, and signal is equal to sig abort, like so, and include signal.h, and we're gonna do just this. We insert foo, it's fine, who cares? Yeah, can I do this? Okay. And make sure it crashes. Yes, it does. Let's put that at top. What else should I try? See, is there like an abort? Anything anywhere else? Just in get. Okay, it's just in get that can crash. Yeah, that seems like a pretty decent implementation. All right. The tests are passing. Let's. Oh, can't do that. Isn't there like a... There is no way of doing this. Okay. Can I do... all dot C X parser. Okay, can I pass that to xargs? Clang format I, like so, and same thing for the header. Right. So slightly cleaner now. Right. Yes. All right. We'll do a little commit and go eat. And yeah. I will do a more generic versions of this after I eat, I think. I think that would be quite fun. By just replacing the key by any key that I want, replacing the value by any value that I want, and yeah. Yeah, I'm not sure yet how I'm gonna handle like void keys and so on, because I have to keep the size next to it and stuff like that. We'll see. I'll try to think about it. So yeah, that seems about right. Did I already did a message? Message. Initial commit with basic hash table implemented with open addressing. Is this how it's called? Open addressing, yes. Open addressing and linear probing. No sign up. Alright. Anyway, see you after.